I'd like to thank everybody who is going to spend 40 minutes or so with us today to talk about a topic that appears to be a little bit old. I want to talk about a modern approach to using CAD viewers in an engineering and product development environment. And as someone last week commented on Twitter, he said, I thought this was an old topic. So what else is more to talk about when we think about CAD viewers? So I want to spend some time with you today and share with you some of my thoughts based on research and customer interviews I had, and suggest that perhaps this is the time to rethink the old notions about CAD viewers and how we can use CAD viewers to vitalize product development using CAD data, or as we said here, democratization of CAD data. As Prashant said, I am a consultant and analyst, and my interests are around product development, overall product lifecycle management as a discipline in software. And a lot of my work is around connected, what I often called, using a very engineering-oriented term, connected stuff. So the Internet of Things, the industrial Internet of Things, which is also the topic of my book, as Prashant mentioned, but really, what happens in a world where everything and everybody is connected, and some of this sentiment, if you will come out, I hope, in our conversation today. So I really wanted to start the conversation today with an observation, and the observation is that most product companies, most product development organizations suffer from acute myopia. Because what happens once your product is sold or installed in the field, you essentially lose sight of its performance. How well the product is doing, how are customers interacting with the product, is it meeting your expectations, is it meeting your overall portfolio expectation, and how about all these kind of features that you spend so much time and money developing and improving? Are customers using it, or perhaps they are failing to use these features? We essentially lose sight of the product. And interestingly enough, when we do have some feedback about the product, when we do have some insight into the product in the field and customer interactions with the product, it's usually in the form of negative reports, whether there are customer complaints, even worse, social media complaints, whether it's about service calls, warranty claims, product recalls. Again, usually what we know about a product is only the bad news. We don't necessarily know the good news. And in all likelihood, the organization's myopia is set up much earlier than just product development. It's really started often during early product planning, product portfolio planning, during the formulation of product market and functional requirements, because often product requirements are based on out-of-date information, the information that has been perhaps true at one point, but it's stale by now. It's often based on biased opinions because we tend to look at data and interpret data the way we understand it, and sometimes the way we want to understand it. And I'll come back to this theme a little bit later in my talk today. So because of this myopia, because of the fact that we don't fully understand the products, and again, our understanding, as it were, started a long time ago, and by now it's stale and inaccurate, there shouldn't really be surprised that many products fail. And I'm sure you've heard these statistics before. A common number that people use is that 80% of products fail. I don't necessarily know that 80% of products totally fail. The number is probably lower than that. But I would agree that 80% of the products or so, at least most of the products, disappoint. They have not reached the goals that we have set them to achieve, whether it's in terms of sales, in terms of customer satisfaction, in terms of their role in the overall portfolio. Most products continue to disappoint us. And I usually use this chart to discuss and highlight why products fail. And you may not be surprised by now that most products fail because there's really no market for them, or the company ran out of cash while trying to pursue this market that never saw the need for this thing. Often we don't have the right team. So again, I use this chart usually when I talk about product failures. But I really want to draw your attention here to the fact that there are so many issues in the reasons why product, there's so many reasons why product fail that are not purely engineering. So it's not, and not purely marketing and functional needs. Look at the kind of major cause of failure, such as not having the right team. That is, the composition of the team was not the right for the product and for the market. How often product fail because of pricing issues? Again, we did not understand the market, and therefore we did not price the product correctly. Or perhaps we have the right target, but we could not achieve the market because our product did not meet cost targets. Poor design and quality. Yeah, you can say this is between engineering and outside factors. Why am I saying this? Is because often quality does not necessarily have to be the utmost quality. Quality needs to be designed based on cost and the competition. There's no need to have super duper quality product if the competition that we're trying to displace is not as strong in terms of quality. Conversely, if you want to chart a new market, perhaps overpaying for quality is the right decision. We have questions about inadequate business models, poor marketing, not understanding the customer in the market. So pay attention to how many products fail, or what is the percentage of failure attributed to the fact that we do not really understand factors that are not pure engineering, but others, marketing, pricing, customers, etc. These are all tasks performed by non-engineering functions within the organization. And also see how often the failures and the obstacles to innovation are again based on team collaboration or lack thereof. Look at reasons for lagging innovation in terms of cultural issues, inability to understand information, inability to act upon information that was available, lack of executive support, again, because executives don't necessarily see engineering, they see other parts of the product life cycle. But fundamentally, it's really questions that have to do with not knowing how to look at data, not understanding market data. And often it's really about not the inability to understand data correctly and to understand what my data, the data that applies to my job function and my actions based on this data, or sometimes lack of action based on this data, what they mean for the downstream. So again, I'm highlighting the fact that we have issues concerning in the way to product success. There are many hurdles that are not purely engineering, but they involve other functions, other knowledge workers, and other tasks and other skills that we'll discuss in this conversation going forward. And you can, I think, agree that these issues cut throughout the product lifecycle. They are not only during early market analysis requirements or even functional requirements and then design engineering. They go downstream. They go into manufacturing. They go into sales. They go into after sales. They go into product support. So they span the entire product lifecycle. And therefore, the product development process, and the success for a product, and must engage multiple stakeholders in multidisciplinary context throughout the product. So the idea is to really front-load decisions that have data sources and data perception and insight into and the entire product lifecycle, front-load decisions so we can understand those issues in advance before we go into product development. So those of you that have been in product development and product lifecycle would say, well, is this not what PLM promised? Was PLM not the promise of a single version of the truth? We thought that the role of product lifecycle management software and the data repositories is really to provide this single perspective of product development and product lifecycle. Therefore, the arguments I made earlier should have been resolved by PLM. I should have been able to understand market requirements relative to engineering, relative to manufacturing, relative to quality, and make the right decisions in front of the process before we engage in design, before we freeze the design. So this was a very noble goal. In reality, it didn't really work that well. Why is PLM, in my opinion, failing to deliver the single version of the truth? Or I might say, more precisely, it does deliver the information, but we, as knowledge workers, as those that use the information, fail to act upon it in a single version of the truth. Why? Because different knowledge workers, different functions have different attitudes and different approaches and different ways to interpret the data in this kind of single version of the truth database. Referring back to one of the charts I just showed, one of the concerns about product development and obstacle to innovation was inability to interpret data. And there are many reasons why people interpret data incorrectly or precisely. First, it really depends on their role in the value chain. So if I'm in engineering, my goals and constraints tend to be engineering oriented. They might have some weight consideration, might have some cost considerations, possibly reliability, but primarily is function. And I really don't understand goals and constraints of downstream processes such as manufacturing, such as service, such as supply chain, because it's typically not within, again, my goals and constraints. So even if I did care about downstream, even if I did understand downstream, my objectives, my goals, and therefore my constraints are not designed and are not defined in a way that understand their impact on downstream. And therefore also my skills, my experience, my mindset is not looking downstream, not looking at the entire product lifecycle, but rather focusing on my own goals and constraints. And this drives into deeper into professional habits and culture biases that always exist. Because we all tend to look at the world through our eyes, again, through the framework of our goals and our constraints, and we develop even cultural biases. And in today's world where open innovation is part of the process, where outsourcing is part of the process, where manufacturing can happen away from design, those differences are really accentuated, and they are much more prone to cause issues because, again, we're involving different locales, cultures, local habits, local regulations, etc. So our ability to interpret the data is really impacted very severely, and we do not understand the impact of our decisions, or sometimes lack of decisions, on downstream. We tend to operate within our own proverbial silos. So the question is, if this is true, or if we want to test this hypothesis, what if we changed our approach? What if we, again, try to fulfill the promise of PLM, but what if we give all stakeholders, or at least some of the stakeholders, some of the key stakeholders, what if we give them access to all the data? So what if we give engineers access to supply chain and service? What do we give purchasing people access to CAD data in order to help them in their job? What would happen? So it's not a hypothetical question, because I want to share with you a couple of use cases that I've researched in trying to understand what happens when we give more people, more stakeholders in the process, access to other data. So an interesting use case is from Backlighting. Backlighting is a Serbian manufacturer of lighting. They make architectural lighting, they make medical lighting, they make industrial lighting, they do kind of stadiums and sport arenas and outdoor lighting. So they cover a very broad range of lighting. And it's considered to be a very innovative company. They won multiple awards for innovative design and innovative styling. They wanted to backlighting, that is, wanted to kind of experiment with what happens if they provide the purchasing people, the buyers of components and raw materials, access to all product information. In other words, they wanted to take non-engineers and give them engineering data that in their case was stored in the CATIA CAD software to really help them understand the parts they were sourcing or outsourcing or buying, depending on the part itself. So what they did, they at Backlighting, they gave the purchasing department a CAD viewer that happens to come from HCL, a Glovius CAD viewer. So what happened when all of a sudden purchasing people that typically, in the best case, look at 2D blueprints? What happened when they had access to the parts? So what had happened, all of a sudden the decisions, the purchasing decision became so much more efficient and more accurate, because they had precise understanding of the data and they could negotiate better. They could get better design reviews, or before that they got better reviews of quotes. They facilitated design reviews more effectively. And interestingly enough, and to me it's not a small thing, it really raised employee satisfaction and engagement in the process. Because if you think about your organization, very often people in purchasing are really not part of the excitement. They're not really part of the life cycle of the product. They tend to get specifications, and then the instruction is go buy the cheapest part you can get that meets these requirements, which is probably not the right direction anyway. But they don't feel part of the decision-making process. They don't even understand where they fit. And the quote there is not a precise quote because I did not remember it precisely, but it really says the sentiment of the conversation. One of the ladies said, now I finally understand where the parts that I specify, the part that I negotiated and buy, where do they fit in the big product? I never understood this before. And you might say it's a small thing, but to me, the sense of belonging and being part of it and influencing it is important. And this really encourages this lady to make better decisions in speccing up our parts more precisely, negotiating more effectively, and essentially getting a better deal for the requirements. So as I said earlier, the purchasing department at Buck was using the Glovius viewer, and the data was in kind of a standard third-party CAD database. So the question is, why do we really need another CAD viewer? Does the PLM software, does the CAD software not have a viewer? So why are we engaging now in buying more software, training people to use new software, managing licensing of new software? What was the deal? Don't CAD and PLM packages offer enough functionality? So the answer could be, in principle, yes. In principle, you can get CAD viewers, and you can, from the vendor of the PLM software, you can get some free stuff that you download from different sources. You could do that, but I think that the example at Buck actually demonstrated it needs to be kind of the right viewer, in the sense that it needs to be usable by those individuals. It needs to be, free is nice, but it needs to be usable by what I call citizen engineers. And well, not to mention the fact that sometimes these CAD viewers are not necessarily free. But again, the question should be, is the CAD viewer that we are offering those non-engineers, is it usable by non-engineers? So look at this user interface. I don't know if this is the kind of user interface that the lady from purchasing at Buck's Lighting was interested in using. These are people that are used to essentially 2D blueprints. So the migration from simple 2D to complex UI doesn't really work well for them. So what we're looking for in order to provide non-engineers with good access to CAD data, we want something that is usable in terms of user interface and workflow, but it also needs to provide some minimal set of essential tools that go beyond just the viewing. For example, of course, we want to be able to view assemblies, but we want to provide, again, I'm thinking from perspective of maybe a purchasing person. I want to be able to perform accurate measurement on the model. I want to do some basic sectioning and assembly analysis. It doesn't have to be detailed. It certainly does not have to be as detailed as the design engineer needs it, but basic sectioning and assembly decomposition might be useful. And a useful area is design for manufacturability, which is, again, in some organizations, a little bit of a weak point. So, for example, it would be very useful for manufacturing engineers, rather than using the full-fledged CAD software, to be able to do some basic computation of material distribution and thickness. And this is actually, interestingly enough, is a hot topic today, because as many organizations move from traditional manufacturing processes and methods to additive manufacturing to 3D printing. Issues around material distribution and wall thickness and removal of support structure become a more complex issues. So it would be nice if we had a tool that allows manufacturing engineers to do a very basic analysis of material distribution. Another area in manufacturing would be calculating draft angles for injection moldings and forecasting. Again, you don't need a full CAD package for it, but you do need to know those attributes in order to design the process properly. And in a similar way, I guess if you think about casting process, think about projected areas and so on. And I'm going to talk about manufacturing in a second as well. Does the tool allow efficient annotation and collaboration? Because it's all about collaboration. I want this tool to foster an approach that drives productive exploration and collaboration between the different disciplines. So now we have a possibility for a purchasing person to come back with alternate designs, alternate sources, and have engineers look at the different options in a different way, consider not only form and function, but also cost, and also manufacturability, and in some instances, serviceability, and so on. So it's really all about democratization of the CAD data. We offer here discussions about this, and the term is very kind of common, but I think it's slightly misunderstood. So what do we really mean by say democratization of data? Does it mean really every person needs to get the data? And I think it's an interesting conversation to have when we think about the use of CAD data and for that matter, any other part of product data. So I think that we are moving into an area, or we should be moving into an era rather, where we can treat everybody in the value chain of a product as an engineer. But of course, they're not engineer per se, so we'll call them citizen engineers. I think that we need to involve portfolio and product planners in the mix, for example. They need to be part of the conversation. As we already touched upon, purchasing and supply chain decisions need to be part of the conversation. We also mentioned manufacturing and service considerations. Again, that's part of a conversation. And of course, today, and I mentioned this in the beginning, it's all about the Internet of Things. So the Internet of Things, the IoT itself, things such as instrumentation of equipment, connectivity, etc. These are engineering functions, so they stay within the traditional boundaries of engineering. But seriously, the real opportunity in the Internet of Things is not the design. The business value is really not in the design, but rather in enabling new business models. It's in creating new customer engagement paradigms. So these are not engineering functions, even though the core technology is by engineering. So these are not engineering decisions, and therefore we need to involve other stakeholders in the value chain in making those decisions. We essentially making them citizen engineers. They all influence the design and manufacturing, of course. So in summary, the non-engineering decisions that influence both engineering and manufacturing, as well as product lifecycle, an entire product lifecycle, need to be part of this community. Now, giving access to everybody and giving everybody a way to use the data and express it does not mean it's a democracy. Nor does it mean, of course, that it's an anarchy. That is, every team member just goes there and makes decisions on their own because they can look at the 3D model. Obviously, engineering has the right and the obligation to override others. For example, safety issues, quality issues. So again, citizen engineering does not mean a democracy. But the visibility to all product lifecycle attributes can help optimize other decisions. And I touched upon this earlier. And visibility to all phases and understanding the impact of decisions, and again, sometimes lack of decisions or downstream, is critical to understanding the entire product lifecycle in terms of quality, in terms of cost, in terms of supply chain behavior, in terms of warranty claims, the entire product lifecycle. So, but the visibility allows you to really make those highly optimized decisions early in the process, the way that PLM always promises us to be able to do. So for instance, you can think about calculating cost of quality. And again, cost of quality is not a factor of only these two factors, but rather it's in the context of your portfolio, it's in the context of your competition, etc. Another area where you can optimize decisions by having this better visibility is manufacturing methods. Again, we talked about 3D printing. So traditional manufacturing, casting, or 3D printing. It's not only a technology question, it's also a question of cost and time to market and quality, etc. And a topic that has been neglected for many, many years is serviceability. Do we now have the ability to understand serviceability goals and apply them early in the design? And perhaps, just perhaps, we decide to invest more in serviceability in order to gain downstreams in terms of lowering service costs and lowering warranty costs. In case you're curious about the pictures, so I mentioned democracy. So this is Cleisthenes, that around 500 BC was the first one to describe democracy. And the guy on the left is Pierre-Joseph Proudhon. He's French, like early 19th century, and he's considered to be the father of anarchism, which is non-government, and libertarianism. So he's the father of libertarian party, if you will. Back to our topic, though. So here's another example of citizen engineers, in this case in supply chain collaboration. The customer here is an India-based subsidiary of a major Japanese car maker. I cannot name them today, but it's one of the largest OEMs in Japan. So the company in excuse me, the company in India manufactures and sells those vehicles that are designed in Japan. They make them and they sell them in India. And as part of this process, part of the manufacturing process, the company subcontracts the manufacturing of stamping dies for panels and other sheet metal products, just like the one you see in the picture here. They are designed in Japan, and so they outsource the subcontract the manufacturing of dies to a local manufacturer. So to make sure I explain it correctly, the parts are designed in Japan, they're handed over to the subsidiary in India, then in turn negotiates agreements with subcontractors to make the stamping dies for the panels that you're seeing in front of you. So this company again uses the same viewer from Glovius, and they use it to review and communicate specifications and conduct design reviews with these local die manufacturers. And as it turns out, the use of visual collaboration, the ability to look at designs through a relatively straightforward user interface, not the full-fledged complex CAD user interface, but again, seeing very precise measurement, being able to rotate effectively and section and understand the design process effectively, and in the process of dies have all the other calculations to be able to manufacture dies correctly. This will help a lot in making not only better decisions, but also making improving time to market and improving yield. The reason, as far as yield is concerned, the reason was that the visual collaboration allowed the Indian car makers make sure that the die manufacturer applies best practices that ensure quality, better quality and faster manufacturing ramp up. So now you have visual collaboration that not only ensures that specifications are correct and dimensions are precise, but rather that in the process, best practices in terms of die manufacturing are implemented. And this would not have been possible if they were not using visual collaboration, using very precise information. So this is again an example of visual collaboration using CAD Viewer in supplier negotiation and subcontractor negotiation, and enables high quality of dies and faster time to market. Now, I think this is very cool. I think this is kind of interesting. I think it's a good thing to do. But I know that life is a little bit more complex, and changing the organization to think this way, to operate this way is difficult. And as Peter Drucker said, culture eats strategy for breakfast. In other words, this could be a great idea, but the organization may not necessarily be able to go after it so easily, because the concern is always that giving more information is going to likely uncover weaknesses in current processes, and which immediately elicits resistance. They're concerned about maybe leakage of proprietary information, and potentially the concern is that people will become, as I mentioned earlier, anarchists and use information inappropriately, or will feel they have greater rights to it. I sense there's resistance to the whole idea of citizen engineers, and I've seen this before. So as we're thinking about this approach, we're thinking about using information to improve decision making. The idea of using citizen engineering to front load decision of PLM, we need to really work hard to change the mindset inside our organization. And I want to suggest an approach to doing it, which is not necessarily going to be new to you, but it's a way to think about introducing those ideas to the company. So first, we need to think about articulating the value of having citizen engineers and articulating the life cycle value of these decisions. So it's really more a question. It's not a question on which CAD viewer I'm going to use and which one is better for the purpose, but rather how do we demonstrate the life cycle value of front-loading decisions using citizen engineers. And the way to do it is really to go back to the reasons for product failures I discussed earlier, and identify weaknesses in your process and identify those that can be improved by better collaboration. And collaboration has become a little bit of a kind of cheap word because everybody thinks collaboration is good, but we know it's very, very difficult to do that. It's difficult to do because as humans, we don't always do this well. We resist change. We resist people who kind of walk into our turf. So I can just imagine some engineering organizations' response when someone from purchasing walks in with a better idea. But the whole idea of encouraging participation also drives contribution and drives dialogue. And as I mentioned earlier in the case of backlighting, it really improves employee satisfaction, which in turn drives better contribution and thinking outside the box, and almost the courage to try new things, as opposed to not having the data, not having the foundation, not having therefore the courage to offer new and different ideas. And again, I'm going to repeat the point on purpose. Product success is more than just engineering specifications and good design. Product lifecycle success means all the parts of the value chain need to work in sync, and sometimes engineering pay more in order to gain downstream. But we need to give the organization the way to think about it and the way to measure and prove it that this approach is appropriate. I think that the two examples from backlighting and the automotive OEM I mentioned prove the point, but you have to do it for your own organization as well. And this will be part of curing the organization myopia that you suffer from. It's not going to be the fix for everything, but it will be part of the cure, because it will help you make better decisions that pertain to the product lifecycle, pertain to the manufacturing part of it, pertain to your supply chain, and especially if you have a kind of extended supply chain with subcontractors that make parts, or as I mentioned earlier, make dies and other services. It will really allow better, more efficient value chain collaboration, and will allow sort of outside innovation and process improvement. And I put outside in quotation marks because I didn't mean outside innovation as in open source innovation or going really outside of the supply chain, but rather inside the organization. So I treat innovation, as it were, or process improvement that comes from purchasing as outside innovation because they're outside of engineering. So it's really the approach of giving everybody access to the data enables those other functions to innovate and be part of the process improvement. It will certainly improve our visibility to downstream activities and understand impact of decisions on downstream. I just a few seconds ago talked about design for manufacturing tasks. And this is not a replacement to manufacturing engineering, certainly not a replacement for simulation and other analytic tools that they employ, but it really allows it to do some light design for manufacturing tasks, maybe kind of back of the envelope assessment, or a way to assess a single point of quality spill before we go into full-fledged analysis. We talked about supplier communication and negotiation. That's a very, very effective way of doing it. And perhaps more obvious, but nonetheless important, is improved documentation and improve our ability to reuse designs, reuse supplier relationships instead of specifying and reinventing the wheel again and again and again, as I guess most of us do. Well, I hope this was useful. I hope this gives you some idea about the notion of citizen engineers and how modern CAD viewers allow you to evolve and improve the notion of designing of citizen engineers in order to improve decision making in product engineering and indeed throughout the product lifecycle. We put some contact information for you to contact us. I'm always happy to continue the dialogue, share information, get comments and disagreements on what I suggested, and of course we're happy to share the presentation slides with you if you're interested in having them. Thank you so much.